Welcome student to this series of lectures on statistics. And in this series of lectures on statistics, we have completed discrete probability distribution. We entered into the continuous probability distribution, and there we have completed normal distribution. And in the last lecture, we discussed that why we need t-distribution when on earth we have normal distribution. Okay, so we understood the intuition behind the t-distribution, that okay, the world has a randomness, the world has uncertainty, and the normal distribution is too perfect for the prediction for those uncertainty and a randomness of the world. So we have to fall back to a distribution which is worse than the normal distribution, bad respective to the normal distribution. It should not be as good as normal distribution. We need such distribution. And that distribution is t-distribution. Okay, so we understand thematically that why we need t-distribution. But for CFA and FRM curriculum, it is important that you understand t-table in the t-distribution universe. You can read t-table to do your prediction and to perform hypothesis testing. We haven't discussed hypothesis testing, but at least we'll build some intuition that how we can do prediction with the help of t-distribution, right? Okay. So now you would say, what is this t-table? Do you remember z-table? What was z-table? Z-table was the collection of the probability that is coming out of probability density function through integration. The same way, all the integration of the probability density function of the t-table has been performed, and all the probability got saved in a table that is called as t-table. Now, why we have to look into this t-table? Because when we do the prediction, we speak in the terms of probability. We never say that we are 100% sure that the stock return would be 5%, or we never say that we are 100% sure that the stock return would be between 4 to 5%. We cannot say that. It would be absurd to speak in the terms of 100% confidence or 100% probability in the world of statistics. Otherwise, what is the need of statistics? You're studying statistics to do the prediction with the help of probability. If anybody on the planet can come and say that I'm 100% sure that the stock return would be 5%, what is the need to study probability? What is the need to study statistics, right? Because nobody can be 100% sure. Nobody has the crystal ball to see the future. That's why we are studying probability distribution, and that's why we are so much focused toward speaking in the terms of probability, and those probabilities are stored in t-table. This is important. Okay, so what we'll do today in this session, we'll first try to read t-table. We try to understand if we are able to read t-table, and then we'll solve three questions, three examples through which we'll try to test our understanding about the t-table, whether we can read t-table, whether we can understand t-table or not. So let's invest 5 minutes of our time on the t-table. So the end result of studying t-table is to speak probability if you know the t-statistics, or speak or tell t-statistics if you know probability. So any one of the information you should be aware. Either you know what is t-statistics and you have to tell the probability, or you know probability and you have to speak in the terms of t-statistics. So input could be probability, so the input could be probability and the output could be t-statistics, or the input could be t-statistics and output would be probability. And that is what is the one-liner use case of t-table. You get the probability, you tell about the t-statistics. If you know the t-statistics, tell about the probability. That's it. Okay, but what is t-statistics? Do you remember z-score from the normal distribution? What was z-score in the normal distribution? It was distance from the mean in the terms of standard deviation. So we cannot use z-score because z-score is only applicable or used for normal distribution. There should be a terminology associated to distance from mean in the terms of standard deviation. In t-distribution, we call it as t-statistics. So distance from mean in the terms of standard deviation. Distance from the mean in the terms of standard deviation, that is your t-statistics. How many distance away your point is from the mean in the terms of standard deviation. For example, I have a portfolio return of say 5%. I have a portfolio return of 5%, and I want to know that I have a value which is 8%, and I want to know 8% is how many standard deviation away from the mean, and the standard deviation is 3. So 8 is how many standard deviation away from the mean? It is only one standard deviation away from the mean. So 1 will become the t-statistics, or you can say the t-statistics for 8% is 1. Okay. Or the question would be 11% is a point estimate, and you want to know how many standard deviation 11 is away from the mean. So 11 minus 5 is what? The mean return is 5, it is 6%. But 6% not in the terms of standard deviation. So what is in the terms of standard deviation? It is 2 standard deviation away from the mean, right? Because 6 divided by 3 is what? 2. Standard deviation given is what? 3. So 2 standard deviation away from the mean. So what is 2? 2 becomes T-statistics. Or the question would be that if the portfolio return is 5% and standard deviation is 3%, then tell me how many standard deviation 2% is away from the mean. It is minus 1 standard deviation away from the mean, right? It is minus 1 standard deviation away from the mean. So T statistics is minus 1. Okay, so that is T statistics, distance from the mean in the terms of standard deviation. Okay, so what is the responsibility of T table? The responsibility of the T table is to either read T statistics and give you probability, or read the probability and give you T statistics. That's it. But let's have a look on the T table. This is the general format of the T table. Most of the time you will see this T table, even in your examination. See, in the real world, you don't have to use T table because if you're using Python, there is already inbuilt function to give you probability or T statistics directly from those function, because those function have inbuilt probability density function embedded in those function. Or if you're using Excel, the functions in the Excels are smart enough to give you T statistics or probability. But in your examination, the test is around whether you can study and read T table and give the requisite information asked in the question. Okay, so let's read this T table. There is something interesting in this column. This column says degree of freedom. Super, super important. We discussed in the last session that T distribution is not only one distribution, it is a family of distribution. If this is a perfect normal distribution curve, the T distribution, where the degree of freedom is say 30, the new T distribution would look like this. It would have a fatter tail than normal distribution and lower peak than normal distribution. But if the degree of freedom further decreases, then the distribution shape changes. If it further decreases, the distribution shape further changes. You're going towards much worse distribution than the previous distribution if the degree of freedom decreases. What is degree of freedom? Sample size minus 1. That is degree of freedom 1. That is the degree of freedom. Sample size minus 1. What is degree of freedom? Sample size minus 1. So if the sample size is decreasing, the uncertainty is increasing, and that's why you're falling back to the bad distribution. So see what is happening in this table. 1 degree of freedom, 2 degree of freedom, 3 degree of freedom. So this complete row is representing one distribution. This complete row is representing one distribution. And you are having a different shape of the distribution at different rows, because every row here is representing different shape of T distribution. It is talking about the T distribution, but T distribution is the family of distribution. The last row is actually the best shaped distribution, and it is the normal distribution. It is very near to normal distribution. You can test it later on after the session. But as the degree of freedom decreases, at this degree of freedom, you have a bad distribution respective to this distribution. For this degree of freedom, you have much worse distribution than the previous distribution. For this degree of freedom, as the degree of freedom is decreasing, the distribution shape changes, and it is becoming worse and worse than the previous distribution. So every row in this T table is representing what? A T distribution of a different shape. So this is where the family of distribution is hidden. One. The second, where is the probability? The probability in this section only. The top 2, 3, 4 rows will have your probability. Now it is saying one tail, so it is talking about probability in one of the tail. There is two tail, it is talking about the probability in combined two tail. So this section is about probability. In Z table, if you remember Z table, the probability was in this section. No, in T table, probability is in the top 2 or top 4 row. It depending upon it is one tail, two tail combined, or it is only one tail, or it is only two tail. Generally, you will receive a combined probability for one tail and two tail. Okay, this is the general format. Then what is this section? What is this section? What is the center? The center is the T statistics. What is the center? The center is the T-statistics. What is T-statistics? T-statistics is the distance from the mean in the terms of standard deviation. What is this section? Probability. What is this section? Degree of freedom representing different shape of T distribution. What is this section? T-statistics. Now, we understood where is T-statistics. We understood where is probability. We understood where is degree of freedom. So what we have to do? We have to look into some of the example and try to test ourselves whether we are able to convert a probability into T-statistics or not. Okay, so let's read our example. The portfolio return is assumed to follow a T distribution. So basically I'm saying I'm taking a sample and the sample distribution is T distribution with a mean return of 5% and the standard deviation of 3%. So portfolio return is T distributed with a mean return of 5% and the standard deviation is 3%. The first question is for degree of freedom 30. If the degree of freedom is 30, please understand the sample size is 31. And for 31 sample size, you have calculated the mean return and the standard deviation. Find the 95% range of portfolio return. Most important, a very big assumption in this question is that the portfolio return is T distributed or the sample return. I'm not saying sampling return. Sampling return is a very important concept, but the sample return is T distributed. Very important, otherwise the whole question would be different. And you don't have to worry about sampling distribution for the time being. Find the 95% range of the portfolio return. Symmetric to the mean. Symmetric to the mean. So basically, tell me what is the range of portfolio return at a 95% probability. So we know whether it is normal distribution, T distribution, or any continuous distribution, the area under the curve is equal to probability. So what do you have to do? You have to cover area under the curve symmetrically from the mean in the left and the right direction such that it covers total 95%. So you will cover 47.5% in this section and 47.5% in this section, right? So you're moving symmetrically in both the direction. So this area is 95%. So this body of this distribution, which you have covered, has a 95% area. So this is 95%. But the problem with the T table is it doesn't speak about probability in the body. It only says probability in the tail. Probability in the tail. For the time being, we'll only focus on two tail. Why? Because you can see we need the area in the two tail. If the area in the body is 95%, what should be the area in the tail? It should be net 5%. It should be net 5%. And if it should be net 5%, combine both, it is 5%. And if you're symmetrically moving in both the direction 47.5, 47.5, and if T distribution itself a symmetric distribution, what should be this area? This area in one of the tail, 2.5%. So area in this tail is 2.5%, area in this tail is 2.5%. So my question is, the example given, my question is, even the example given saying 95% probability in the body, but it is very simple to convert it into the probability in the tail. So two tail combined area is what? 5%. So this is 5%. You look into this column. Or you can also say that one tail area is 2.5%. You still look into this column. Right? Two tail combined area is 5%. Or one of the tail has the area of 2.5%. You don't have to refer to two different column, only one column. So one thing is sure that we have to study this column. Perfect. Where the probability in the two tail combined is 5%. Or probability in one of the tail is 2.5%. But which row to study? It depends upon what? The degree of freedom. What is the degree of freedom? 30. So for 30, this is the row you have to study. So this column and this row. So you have to actually look for what? 2.042 as T statistics. What is T statistics? How many standard deviation you're away from the mean? So basically this point is 2.04 2.042 standard deviation away from the mean. 2.042 standard deviation away from the mean. And this point is also 2.042 standard deviation away from the mean. So 5, so what do? You will do 5 minus 2.042 into 3. And this point is 5 plus 2.042 into 3 standard deviation away from the mean. So let's calculate the value. So 2.042 into 3 will come as 6.126. So 6.126 plus 5 will become 11.126. And if you subtract it from 5, it will become negative 1.126. Now, basically, what it means, what these two numbers represent. These two numbers represent the range in which your return will fall at a 95% confidence or probability. So you will say, I'm 95% confident that the portfolio return will fall between negative 1.126% and 11.126% if the portfolio return is assumed to be T distributed. Okay. So this is question number one. Question number two. Now, question number two is saying, hey, the degree of freedom has changed. Now, the degree of freedom is 20. Find the 90% range of the portfolio returns symmetrically from the mean. So basically, now the probability has changed in the tail. So if you have to cover 90% probability in the body, then how much area would be in that both tail combined? It would be 10%, and each tail it would be 5%. So let's look for two tail and 10% or 5% for one tail. In both the situation, you have to refer to this column. Now, but the degree of freedom is 20. The degree of freedom of 20 means that you have to study this row and this column. So this row and this column will give you T statistics as 1.725. 1.725. So which means that you have to move 1.725 standard deviation in the right direction, 1.725 standard deviation in the left direction, symmetrically from the mean. So 5 minus 5 plus. And you'll get the value. You'll get certain value. But what is important? Understand. See, you're moving from degree of freedom of 30 to degree of freedom of 20. So what is happening? The confidence interval is increasing. Why? Because the T distribution becomes wider and wider because you're moving to a worse distribution. Why you're moving to a worse distribution? Because the degree of freedom is falling. Why degree of freedom is falling? Because you're now talking about 21 sample size. Therefore, the degree of freedom is 20. Lesser the sample size, more uncertainty in your prediction. Okay. Let's calculate the range and test whether the the confidence interval or the range has become wider or not. It should be wider. It should be wider, but wider at 95%. But we are calculating at 90%. But still, if we would have calculated at 95%, it would have been a wider. At 90%, it won't be wider because you are changing the probability. Okay, let's calculate for 90%. So 90%, 5% minus 1.725 into 3, 5 plus 1.725 into 3. And this would be your range at 90% probability. If you would have calculated at 95% probability, at 95%, this is the column you will refer, and the degree of freedom has decreased to 20, so you'll refer to 2.086. So if you calculate the range at 2.086, definitely the range would be wider than what you have calculated at 2.042 in the left and the right direction, right, at 95%. Okay, so we solved the two question. The last question is slightly different than these two questions. Now, in this question, the last question, we are giving you a point estimate and we are asking to calculate the probability. In these two questions, the probability was known, not in the tail, but in the body, but the probability was known and you were trying to find out T statistics. Now, in this question, you're trying to find out probability with the help of a point estimate. Okay. So the degree of freedom is 15. When you see the degree of freedom 15, you should understand that the quality of the distribution is decreasing. So this is the degree of freedom and the T distribution would be slightly wider and the peak would be lower. Okay. Find the probability that the portfolio return would be greater than 10.259%. So basically, the mean return is still 5%. The mean return is still 5%. And you're saying that, hey, in the right hand direction of 5%, there is a value which is 10.259%. And you have to say, find the probability that the portfolio return would be greater than. So you are interested in which area? This area or this area? Greater than. So you're interested in this area. If you find this area, this will become the probability because area under the curve in the continuous distribution is equal to probability. So you have to find out that what is this area. But the first question is, if you're trying to find out the area, you need T table, that's fine. And you're interested in area or you're interested in finding the probability. But for T table, you need the input of what? T statistics. What is T statistics? T statistics is how many standard deviation you're away from the mean. So 10.259 is how many standard deviation away from the mean? It is 5.259 standard deviation away from the mean, but in the terms of standard deviation. So 10.259 minus 5% upon 3, which is again x minus mu upon sigma. 10.259 minus 5 upon 3 will give you the value of 1.753. This is your T statistics. This is how many standard deviation you are away from the mean. So you have to find out 1.753 for which degree of freedom, for which T table, or which T distribution. Sorry, not T table, for which distribution. The T distribution which is associated to the degree of freedom 15. First of all, let's go to the degree of freedom, that is 15. For this 15, you have to look for the value 1.753. This is the value 1.753. So 1.753 is associated to a 10% probability in two tail and 5% probability in one tail, right? You're interested in one tail or two tail here. You're interested in one tail. So area for this probability is what? 5%. Because that is the probability given for one tail, 5%. So you can say there is a 5% probability that the portfolio return will be greater than 10.259%. Or you can also say that there is a 95% probability that the return of the portfolio would be less than 10.259%. And you can also say there is a 45% probability that the return will be between 5% and 10.259% because this area would be 45% because T distribution is a symmetric distribution. Okay. So this complete area is 50%. If you're covering 5% in this area, the remaining area is what? 45%. So 45% probability that the return will be between 5% and 10.259%. Okay. With that, I try to build up the intuition to read T table and help you convert the T statistics into probability and probability into T statistics. Always remember that as you're moving towards band distribution, your confidence interval will increase, your range of prediction will increase because bad distribution means bad quality of prediction. And that's why you cannot be 100% sure or 95% sure with a narrower range of returns or narrower range of estimates. With that, I'll pause here. Thank you. Have a nice day. We'll see you in the next session.